Hey, hi. In this particular video, we'll be talking about a miscellaneous problem. So let's say you're given the value of n, okay? So n is given to you in the input, and let's say n is up to 10 to the power 6, okay? So given n, you need to find the number of solutions that this equation has, where a and b both belongs to integer, okay? And n and in the input will not be like 0, like it is greater than or equal to 1, okay? So given this input n, find out the number of pairs of a comma b that exist so that this particular equation is satisfied, okay? So pause the video right here and think about this particular equation and how do you like count the number of pairs that exist, or in fact find the pairs that exist so that this equation satisfies for a given n, okay? So I'm assuming that you have thought about this particular expression over here. So let's try to manipulate the expression a bit, okay? So we will take the denominator as common and we'll have a plus b in the numerator and a into b in the denominator, and this would be 1 into 1 by n. Let's cross multiply, so we get n a plus n b equal to a b, right? Let's bring both of these to right hand side. Okay. So we have ab minus na minus nb equal to 0, right? So this is somewhere we can reach to, but still even if you now know the values of n, there are still too many variables to sort out for, right? So next we will look at how we can manipulate this expression from over here. You can pause the video here and think about how you can like proceed from this particular expression. So let's talk about how do we proceed from this. So the trick for this particular problem would be to add n square on both the sides, okay? Okay. Now if you look closely, this is nothing but a minus n multiplied by b minus n. Why? Because there's a like, if you take common a out of this is b minus n, and if you take n out of this is b minus n out of this would be b minus n, and then this would be a minus n multiplied by b minus n, right? So this is a minus n multiplied by b minus n equal to n square, right? So if you think about this there is this one term and this second term, and then there is this third term, okay? So let's call this x y equal to z, right? X into y is equal to z, okay? Now we can assign a and b anything, whichever we want to. So we know n, right? So as soon as we fix a, b gets fixed. Make sense? So now what are the different values a can take? Any of the divisors of z, right? So we can, what we can do is we can iterate on the divisors of n square, okay? So let's say n square has divisors d1, d2, d3 and so on, okay, dn, and assign each of them, like let's say we assign d1 to this, and correspondingly like n square by d1 gets assigned to b minus n, and if a minus n is equal to some d1, then we can find the value of a equal to d1 plus n, right? And similarly b would be equal to n square by d1 plus n, okay? So we can find this particular form. So and d1, it can be generalized to be some di, where di is the divisor of n square, right? So this would be like the general form of the solution, and since n is up to 10 to the power 6, we can factorize n square using the root n technique, and we can iterate on all the divisors if we want to, okay? Now one more small thing that you will have to note into this particular problem, that the numbers can be negative as well, right? It's an integer. So what we can have is minus d1 and minus n square by di as well, okay? So what we can do is, with these di's possible, we also consider the possibility of having minus d1, minus d2, minus d3 and so on up to d minus dn being assigned to this first part, okay? And similarly the second part automatically gets allotted, okay? So using this particular style, you can find out all possible assignment to this expression, and for each of these, this gets fixed because n square is fixed, and once these two gets fixed, you can find out the values of a and b and print out there, okay? So n square is up to 10 to the power 12, so there would be, we know that the number of divisors of this can at most be 2 into root n, and in this case, since we are making it negative as well, we have 4 into root n, but that is still up to like 4 into n power 6, so we can still find all the solutions if we want to. Okay, so that's all for this particular problem. See you in the next video.